Okay, hello everyone. In this part, we are going to introduce the feed AP based networking and configuration. Feed AP should work together with AC. And in a feed AP and AC network, feed APs are only responsible for the encapsulation, communication, running wireless standards, and set out signals, while ACs are mainly responsible for the control plan. For example, policy control, ensure mobile security, support stateful firewalls, and include wireless IDP and some other features. If we build a feed AP and AC network, all the feed APs require no configuration and do not need to be configured before we install it. AC centrally controls, manage, and configure the APs. The combination of ACs and feed APs is used on enterprise WLANs because ACs can simplify the management and configuration of numerous APs. So from here, we can know that the feed AP and AC networking is more suitable for the large-sized network. Because in the large-sized network, we should, for example, we should cover a campus or we should cover a building. So we should have multiple APs. If we use Fed AP in this scenario, it's very difficult for us to manage all of them, to configure all of them, to maintain all of them. But while if we use Feed AP and AC, all the APs is centrally managed by AC, it will simplify the configuration, the maintenance, and the management of the network. This is the reason why we say it's more suitable for the large-size network. Ruijie's feed APs can switch to Fat AP mode. They are integrated feed and Fat APs. So when you use APs, especially the new AP, so you should check the mode of it, because by default it's feed AP, and if you want to use a Fat AP mode, you should manually adjust it. Okay, and the ACs manage and maintain all APs on the entire network. Manage and maintain. This is a control plan, right? And aggregate data. This is the forwarding plan. Aggregate data from different APs. Here I want to ask a question because we have already introduced the data forwarding mode. So the aggregate data from different APs mentioned here can tell us which mode or which data forwarding mode is using. Because the forwarding modes can be divided into centralized mode and local forwarding mode. So if the AC will aggregate data, means we're using the centralized mode, right? I think you still remember it. Except that AC supports users' security control, service control, charging information collection, and network monitoring. So you can find it's powerful, right? If you use the feed AP and AC networking, it have following features. First is the centralized configuration delivery and the unified AP management and maintenance. Last is automatic network optimization. The last one is very helpful to us because the network optimization is very difficult. And if we have ACs, we can use some tools to automatically adjust some parameters. For example, we can adjust the power of APs, we can adjust the channels. So in this way, we can automatically optimize the network to improve the user experience. Okay, in AC and feed AP networking, this is a typical figure, or this is a typical topology. You can see AC has already established the cable tunnel with each AP, and in the cable tunnel, they can transmit a control message First is control message and service data. It depends on which kind of forwarding mode you choose, right? And through the CAPAP terminal, since we can exchange or we can transfer some control message, so the AC can manage and authenticate all APs, provide functions such as security, packet forwarding, radio resource management, queues, roaming, cluster, and so on. So if we use AC to manage all the APs, firstly, the centralized management can reduce the working load of the engineers, and the RF environment can be monitored because all the feed APs are centralized managed. So on the AC, we can check or we can detect the running status of each AP. So we can get the, for example, the RF environment in the whole coverage. And based on the parameters we have got, we can modify some parameters to optimize the network. Except that layer 2 and layer 3 roaming applies to large-scale networks is supported. Okay, this is about the function of AC. And then, if we use the feed AP and AC networking, here it shows us 3 possible networking structure. First is called direct connection. You can see APs are directly connected with AC. It could be a physical cable, or here we could use a switch. Right? For example, we could use a switch or even use a hub here to connect more APs with one AC. Right? It's called direct connection. And the next is called the layer 2 interconnection. Obviously, from the name, we can know that layer 2 interconnection means the network between AP and AC is a layer 2 network. Okay, and layer 3 interconnection means the network between AC and APs are L3 network. Right. So in the layer 3 network, it's a little complex. Right? We should have rules. We should design the IP address, right, of APs, of ACs. Right? Okay, this is about the networking structure. And then let's see the configuration. In this figure, it shows us a typical direct connection between AC and the feed AP. Right? AC is connected with the AP directly, and between them there is a PoE power supply model. Okay, first step is to connect the device. Then we can check the running version on the device by using the command show version. And we can view some basic information about the AC before configuration. Okay, and step 3, configure the DHCP server of the AC and deliver the IP address to AP. So let's see. First, the service DHCP. We have set the AC to be the DHCP server, and we create a DHCP port which is name is AP. IP means this IP port is used to assign IP address for the APs, right? And then network 172.16.1.0, 255.255.255.0. The gateway is 172.16.1.1. And the next is very important, option 138 IP 1.1.1.1. The function of this command is to tell the APs that the IP address of AC is 1.1.1.1. Because we said that between the AP and AC, they should establish a CAPAP terminal. So this is a CAPAP terminal. But to establish the CAPAP terminals, at least they should communicate with each other. So they should send packets to each other. And to send the packet, they should get the IP address of each other. Okay, so in this way, by the option 138, AC has told the AP that, okay, my IP address is 1.1.1.1. So if you want to communicate with me, you can send packets to this IP address. Okay, this is about the function of option 138. And then view the AP information and obtain the IP address information by use command show IP DHCP binding show cap state to view the DHCP address binding relationship and to view the cap terminal connection status. Okay, this is a configuration of the DHCP, and then configure information that the AP sent to users on the AC. Let's see, this is about the users. Firstly, create WLAN 20, and into WLAN 20 means we have created SVI, right? SVI 20. Configure the IP address of it. IP address is 172.16.2.1, and the service DHCP means we have enabled the DHCP service. Here you can think about it. We have set AC to be the DHCP server. And why do we need to set AP to be the DHCP server? Why? Because AC is the DHCP server of APs. It's used to assign IP address for all the APs, while AP is a DHCP server. It's used to assign IP address for all the STAs. The STAs should get their IP address. Okay, so you should know the difference. It's very important. And for STAs, we have created a DHCP port which name is user IP. The subnet is 172.16.2.0, mask length 24, gateway is 2.1, and then create the WLAN. WLAN config 1 Ruijie. This command is important. The command, let's write here, WLAN config. And after WLAN config, there could be three parts. The first part is a WLAN ID. And the second part is optional. Optional means if you do not need, you can do not use it. And this part is called the profile string. Okay, and the last part is SSID. So if we do not have the second part, for example here, WLAN config 1 Ruijie, so 1 is a WLAN ID, Ruijie is a SSID. Okay, and then enable broadcast SSID. We have enabled the SSID broadcast function of the AP, right? Okay, this is step 5, and then associate WLAN 1, WLAN 20, and AP1. So we create a AP group. The name of the AP group is AP. The reason why we should create an AP group is that, for example, in a network, we have maybe 100 APs. And if we put all these APs into one or into the same AP group, so we can maybe configure this AP group so that we can do the configuration to all these 100 APs at the same time. We can manage them together. Okay, so this is a function of AP group. And then interface mapping 120, we have associated the WLAN 1 with STA VLAN 20. AP config AP1, so we have entered the working mode of AP1, and AP group AP means we have added the AP to the created AB group, right? To the AP group, which name is AB. Okay. After knowing the configuration procedure of the FIT AP and AC networking, then let's see a case. Now we have already set up a weird network, and based on the weird network, we should build a WLAN. In this WLAN, all the STAs works in WLAN 10. The subnet is shown here is 10.0.0.0. And for all the APs, they work in WLAN 20. The subnet is 20.0.0.0. Okay, let's see what we should do. First, they set the trunk port, right? On the access switch, create only WLAN 20 to which the AP belongs. Assign the downlink interface of the access switch to WLAN 20 to which the AP belongs. So these ports are WLAN 20. And on the AC, we create only STA WLAN, which is 10. Okay, this is about the first step. And then configure the IP address. First is IP address of the switch and the AC. Right? 192.168.0.1 and 192.168.0.2. And for the AC, it has a loopback interface, which IP is 1.1.1.1. And actually, this is, I think you can figure out that this IP address is used when we configure the DHCP option 138, right? The IP address used to establish the capable terminal with APs. Okay, and then next step, create VLAN and create the SPI interface, configure the IP address, right? Is what we are doing here. And the configuration of DHCP, right? We have two DHCP ports. First is a AP address, and next is a STA address. Both of them should have the gateway, right? And for all the APs, we have enabled option 138. And the IP address we use is what we just said, is 1.1.1.1. Okay. This is about the configuration of DHCP. And on the gateway switch, configure static route to the loopback 0 interface of the AC. Of course, it's a layer 3 network. So on the switch, there should be a route to the loopback interface. And of course, on the AC, there should be a route back to the gateway. Okay, this is about the route. After finishing the configuration here, then let's go. An AP starts without configuration, obtains its IP address, and the gateway IP via DHCP obtains the AC's IP address, right? So this is what AP gets. You can see AP has got an IP address, has got the gateway, has got the IP address of AC. So after getting this information, AP will establish the terminal or will communicate with AC. So let's see it. AP actively established a capable terminal with AC. Of course, it has the IP address of AC right now, right? So you can see they have established the terminal by using the message here, capable request, capable response, right? We have introduced the process before, so I think you can still remember it. Okay, after establishing the capable terminal, then AC will deliver configurations to APs. After the terminal between AP and AC is established, the AC delivers the configuration to the AP, include the SSID, include the mapping between WLAN and VLANs, WLAN security parameters, radio channels, and power, and so on. So after getting this configuration, of course, AP can work normally. So once AP works normally, it will set out the signals so that STAs can scan the network and it can find out the signal, can access the network. Okay, so until now, STA has already joined the WLAN. It can send packets. So let's see. The STA send out the packet. This is a DHCP request. Here, think about why it's a DHCP request. Because STA just joined the network. It do not even have an IP address. So firstly, STA will think that, okay, can I get an IP address? So it will send a DHCP request, right? So it will be sent to AP. And since AP will send it to the weird network, so AP will convert. Let's see. After receiving the data, AP converts the data into an Ethernet data. Add a VLAN tag, add a capable header, add a UDP header, add the source and destination IP address. Then this packet will be sent to AC through the capable terminal. Because you can see it got a capable header already. So the packet is sent to AC, through the Kappa terminal. And after receiving it, let's see what will happen. After receiving the packet, firstly, AC will decapsulate the data. You can see decapsulate data, and this data will be sent to the switch. While before forwarding this packet, AC will learn and generate the MAC address table for the Ethernet data according to the MAC address entries of WLAN 10, because STAs belong to WLAN 10, right? And then the Ethernet data retrieved after decapsulation is a broadcast packet. Of course, it's DSP request, right? The packet is broadcast to the interface of WLAN 10 and is forwarded to the DHCP server. So after receiving that, since it's a DHCP request, so after receiving the DHCP request, DHCP server will send a response. So let's see what's the process. The AC forwards data returned from the WLAN network to AP through the Kappa terminal right now, because once receiving the DHCP request, the server will feed back a DHCP response, you can see. And this response should be sent to AP and AP sent to STA. So let's see. After receiving the DHCP response, AC will encapsulate this packet. So after encapsulation, you can see the result is like this: source IP, destination IP, UDP header, Kappa header, Ethernet header, and the DHCP response. This is a payload. So the format is the same as what AP sent to AC through the Kappa terminal, right? And after receiving it, AP of course will convert, right? Will convert it into a 802.11 data and send it to STA through the wireless network. Okay, this is about the whole process when STA wanna communicate with maybe another unit in the network. Okay, and here it says that the following process, for example, the ARP exchange or even data forwarding, is similar as what we have just introduced. The process is similar. So you can analyze it by yourselves based on what we have just introduced. Okay, after knowing the feed AP and AC networking and the configuration of it and the working process of it, then let's see a question. Which of the following is correct about the commands WLAN config 10, 100, and 1000? Choose A. 100 is the WLAN ID. Choose B. 100 is the SSID. C. 1000 is the name of the signal. D. 1000 is the WLAN ID. Actually, for this command, 10, we said 10 is the WLAN ID. 100 is a file stream, and 1000 is a SSID. So which of the following is correct? Actually, C. I see. 1000 is the name of the signal because SSID is the name of the signal. Okay, so that's all for this part.